Hello, everyone. Today we are talking about transversal and parallel lines. Now, before we start this lesson, make sure you are following the sharing instructions, which are posted here. When you finish your work, make sure you are submitting this link to your slides in the correct Canvas assignment. The instructions for naming and sharing are in this video. Please make sure you are putting your name in front of the standard, which is G6A. And G6A is that I can verify theorems about angles formed by intersecting lines. Now, you should have completed the warm up with us in class. If you were not in class, please open up this Jamboard and on slide 1, add a photo that is an example of parallel lines. And on slide 2, add a photo that is not an example of parallel lines. The other thing that you should know is that this is the only video for this slide deck. We are going to do this slide deck with one video, so whenever you need to type something into your own slide deck, you can just pause this video. And on your slide deck, you should see highlighted blanks in yellow. Anytime you see a yellow highlighted blank, that is a place that you should be typing in. And let's begin. So, let's introduce our topic for today. Our goal is to learn about angles that are formed when two or more parallel lines intersect with a transversal. Now, what is a transversal? Well, here is the transversal definition. A transversal is a line that passes through two lines in the same plane at two distinct points. So if you're looking at this example picture here that I'm hovering over, you'll see that we have two lines. One of them is called L1 and the other one is called L2. And then there's this third line that's passing across line 1 and line 2. That is our transversal. And so you can see that it crosses line 1 at this point and it crosses line 2 at this point. So those are two distinct points because distinct means different, and this point is very different than this one. Specifically, though, we want to talk about what happens when a transversal passes through parallel lines. So, in order for us to discuss parallel lines, we need to have that definition as well. So, the definition of parallel lines are two lines that do not intersect. In other words, we could say that these two lines have the same slope. So in this picture here, we still have a transversal that is cutting between these two lines, but you'll notice that these two lines are parallel and they will not touch each other. They have the same slope. So here is an example of two parallel lines. We have one line here and one line here that are parallel to each other. And we have a transversal cutting through it. Now, I want you to use your intuition, meaning it's kind of like your gut feeling. Which of these eight angles do you think have the same angle measure? In other words, which of these eight angles do you think are equal? And I want you to type your response into this box. And you could say something like, I think angles 1, 6, and 7 are equal. And I think angles 2 and 3 are equal, something like that. But just take a guess. Which angles do you think are equal in this photo? And type your response here. And now that you've had an opportunity to take a guess at which of those angles are equal, I'm going to now give you the power of a theorem that tells you which of those angles are equal. And that theorem is the alternate interior angles theorem. So let's read that theorem. And you're going to be typing this into your box, of course. The alternate interior angles theorem says that when two parallel lines are cut by a transversal, the resulting alternate interior angles are congruent. Now, from before, we know that congruent means equal, but we don't know exactly what interior angles are, and we don't know what alternate interior angles are. So let's look at those definitions as well. Interior angles are angles that appear between the two parallel lines. So those are the angles in between the two lines. Now, the alternate interior angles are interior angles that are on opposite sides of the transversal, meaning they're on opposite sides of this transversal line, and this is a big and, and they have different vertices. Now, if you remember from the angles investigation, a vertex is like the corner point of an angle. It's the point that really makes an angle an angle. So to practice using those new definitions, we could say that in our picture here, the interior angles, which are the angles on the inside of the parallel lines, would be angle 3, 4, 5, and 6. Since those are on the interior of the parallel lines, they are interior angles. Now, to go a step further, our alternate interior angles are going to be pairs. So the angles 3 and 6 are interior angles. They are on opposite sides of the transversal, which is this line. They are interior on opposite sides and they have different vertices. So the angle 3 vertex is here, angle 6 vertex is there. And so 3 and 6 are alternate interior angles. Likewise, we have angle 4 and angle 5. They are interior angles. They are on opposite sides of the transversal. And again, they have different vertices. Angle 4 vertex is here, and the angle 5 vertex is here. So angle 4 and angle 5 are also alternate interior angles. Well, what does that mean? Well, we just had a theorem that says alternate interior angles are equal. So therefore, we can say that angles 3 and 6 are equal to each other. And we can say that angles 4 and 5 are equal to each other. That is using the alternate interior angles theorem. Now, I want you to practice using this theorem. I want you to try and find the angle measures of angle 3, 5, and 6 if the angle measure of 4 is equal to 66. So go back and look at the alternate interior angles theorem. Look at the definition of alternate interior angles and try and tell me the angle measures of 3, 5, and 6. If you need a hint, I would like to remind you that angles 3 and 4 form a linear pair. Likewise, angle 5 and angle 6 form a linear pair. If you don't know what a linear pair is, I would look back at your previous set of notes, or perhaps you have that in your vocabulary maps, or you could ask a friend or a teacher. Now, we are going to talk about the second theorem, and it's kind of like the counterpart to the first one that we talked about. This theorem is the alternate exterior angles theorem. And this theorem says that when two parallel lines, like the ones we have in our picture, are cut by a transversal, which is this line, the resulting alternate exterior angles are congruent. And congruent means equal. Well, what are exterior angles, you might ask? Exterior angles are the angles that appear on the outside of the two parallel lines. So here are the exterior angles on the outside of these two parallel lines. And again, we have these angles are the interior ones. So let's practice using those new definitions and that new theorem. The exterior angles in our picture are angles 1, 2, 7, and 8. They are on the exterior of the two parallel lines. Now, the alternate exterior angles would be angles 1 and 8 because they are on opposite sides of this transversal. Angle 1's over here, angle 8 is on this side, and they have different vertices. Angle 1 vertex is here, angle 8 vertex is there. So angle 1 and 8 are alternate exterior angles. Likewise, angles 2 and 7 are alternate exterior angles because they are on opposite sides of this transversal. They are exterior angles and they do not have the same vertice. So using our theorem, the alternate exterior angles theorem, we can say that angle 1 is equal to angle 8 and angle 2 is equal to angle 7. Now you have the opportunity to practice using the alternate exterior angles theorem. This time, I gave you the angle measure for angle 8. Let's say angle 8 is equal to 57 degrees. I need you to use the alternate exterior angles theorem to find the angle measures of 1, 2, and 7. Now remember, angles 1 and 2 form a linear pair, and likewise angles 7 and 8 form a linear pair. That is all we have in this video today. Thank you for watching. Please reach out to me if you need help, and do not forget to submit this website URL link into your Canvas assignment. See you in class. Goodbye.